So next thing we want to talk about is moments of inertia, and those tell us how hard it is to move an object given that we're standing in a certain place. So, for example, take this, it's a foam roller. Um, if I hold it at the center of mass, or approximately there, not too hard to move. If I hold it exactly at the center of mass, there'll be no like wobbly rotation. It's pretty hard to do that with a thing this long. Not too bad. If I hold it over here on one side, it's suddenly a lot harder to move. I can still do it. It's not that heavy, but let's say this were actually something that I struggle to move at the center of mass, I'm going to have a really hard time moving it at the edge. Think about if you had to pick up a whole bed from the edge of the bed. Well, you could pick up one side of the bed, the other side would still be on the ground. You'd have to be really strong to actually lift the whole thing off the floor, because maybe if you could get under it and get right in the middle and pick it up, if you were kind of strong, you could do that, but you'd have to be much stronger to do that from one side. So that's what a moment of inertia calculates. All right, so in general, your moment of inertia, I'll just write this in words first. So moment of inertia is going to be the integral over your region of distance squared of each point times the density, and then dA. Okay, so what does that mean? Then that means your moment of inertia about the x-axis, we'll call that I sub x. So you didn't have this formula in Math 126. This is new. Distance squared, distance to the x-axis, remember, is y. So it's a little bit weird that subscript again is flipped. And then times the density, rho of xy, dx dy. Or switch the order of integration if your functions are nice and you need to. And then moment of inertia about the y-axis is I sub y, and the integral over the region. Distance to the y-axis is now x, so x squared times the density, dx dy, switch the order of integration if you need to. So what these mean is if you're standing on the x-axis and you're trying to move your object, how hard is it? And let's just say you're standing at the y coordinate of the center of mass. So you're not worrying about wobbling in the y direction. And here, if you're standing on the y-axis, how hard is it to move your object? So of course that depends on where the object is located x coordinate wise. If the whole thing were located on the y-axis and you're standing on the y-axis, easy to move the object. If the whole thing is located really far away from the y-axis, then it's a lot harder. And then maybe the most useful is about the origin. We'll call this I sub 0, integral over your region. And then distance to the origin is Pythagorean theorem, right? If you're at the point x comma y, and your distance is d, then d squared is x squared plus y squared. So we're taking our distance squared still, x squared plus y squared, rho of x comma y dx dy, or dy dx if you need to.